All right, y'all, welcome back. Today we are discussing 5.2 day one, and we are going to talk about properties of exponents. So we're going to split up 5.2 into 2 days because there's a lot of stuff for us to go over. So we're going to do day one today. We will do day one next class. Okay, if you remember last class, we talked about nth roots. All right, and today we're going to kind of expand on that and how we use that. So properties of exponents. So unfortunately, this is not in your workbook. So you're just going to have to write this down on a piece of paper, and you can write as much or as little as you want. But there are 5 properties of exponents that we are going to talk about. Okay, you guys have seen these before. You saw these in Algebra 1. You probably, hopefully, remember most of them, but I just want to refresh your memory. Okay, so the first one is called a product of powers. So basically what that means is that whenever you multiply two things that have the same base, like if you see these two, a to the m and a to the n, if the a's are the same, the bases are the same, then you just add their exponents together. So an easy way to think about it is keep the same base and add the exponents. All right, and I have a couple examples over here. So 4 to the 3/5 times 4 to the negative 1/5. Notice that the 4's are the same, so that means we just add the exponents up. If you add 3/5 plus negative 1/5, that would give you 4 to the 2/5. Because in fractions, when the denominators are the same, you just add the top and keep the bottom the same. So 3 plus negative 1 is 2. And we're finished. Right? So all you do is add the bases, or excuse me, add the exponents together. All right? Second one's the same thing. They both have an x, so their bases are the same, so the x isn't going to change. And then we just add 3/2 plus 1/2. That would be 4 over 2. 3 plus 1 is 4, and 4 over 2 is just 2. 4 divided by 2 just becomes x squared. Okay? So whenever you are multiplying with the same base, you add the exponents. The opposite is also true. Quotient means to divide. So whenever we divide, that's probably a little bit hard to see, we keep the same base and we subtract the exponents. So as long as the bases are the same, we're just going to subtract. So in this case, these both have a 3, right? So they have the same base. So we just subtract 4 minus 2, which would give us 3 squared. Okay, if the bases are the same, you just subtract the exponent. Same thing with this one. They have a y and a y. 5/2 minus 3/2. 5 minus 3 is 2. So it would be 2 over 2, which is just 1. And you don't even have to write the 1 if you don't want to. I'm just going to put it in there so we know kind of where it came from. Okay? So there is when you multiply, add the exponents. When you divide, subtract the exponents. Now what happens if there's one number in, one exponent in parentheses and one outside the parentheses? Okay, you just multiply the exponents together. Okay, notice that the a hasn't changed in any of these. The base has stayed exactly the same the whole time. So the big number, the thing that has the exponent, that's never going to change. So in this problem, that x is not going to change. Okay, there's one exponent inside and one outside the parentheses, so I just multiply those together. So 4 times 1/2 is 4 over 2, which is just 2, because 4 divided by 2 is 2, so x squared. So you just multiply the exponents together. Same thing for this one. The 7 is not going to change. 3 times 1/2, if you have 50 cents and multiply it by 3, you now have 3/2, $1.50, 1 1/2. Okay, so 7 to the 3/2 power. All right. The fourth thing that you might see is when there's no exponent on the inside, right? Like there's no n, like this one had an m on the inside and n on the outside. This one doesn't, but now there's 2 things on the inside. There's an a and a b, not just an a. This is where we're going to distribute the exponent. So that m goes to the a and to the b. Okay, so in this case, it would be 16, distribute the 1/2 to the 16, and distribute the 1/2 to the x. Okay, and we're going to talk in a little bit how to figure out, but 16 to the 1/2 power is just 4. We're going to talk in just a little bit how we're going to figure that out. Okay, so if you're not sure where I got that from, just hold tight for me. All right. Okay. The second example, we're going to distribute this 4 again, right, to everything. Okay. x squared to the fourth. Now notice there's one inside and one outside, right? There's a 2 and a 4. So I'm going to multiply those, and I get x to the 8th. Y doesn't have an exponent written, right? So it's just a 1. 1 times 4 is 4. And then z to the third to the fourth, 3 times 4 gives us 12. X to the 8th, y to the 4th, z to the 12th. Okay? X to the 8th, y to the 4th, z to the 12th. The last one is whenever you have a negative exponent. Okay? Whenever you have a negative exponent, you're just going to flip it. You're going to move it. So this a to the negative m is like a to the negative m over 1. Right? So if you have a negative exponent, just move it to the other side of the fraction, if that makes sense. So this 5 to the negative 1/2 is basically over 1, right? I can put 1 on the bottom. So just move this 5 to the 1/2 to the bottom. And when you move it, the exponent becomes positive. So I just flipped it. Okay, I just flipped it and moved it to the bottom. If it's negative on the bottom, right, just move it up to the top. So when you move it up to the top, it becomes positive 3. So if it's negative, just move it to the other side of the fraction. Okay? Those are the 5 properties of exponents. Now we're going to do a couple problems where we got to use them and like simplify with them. Okay? So here's the first one. Look at this problem right here. So it says 81 to the 5/6 times 81 to the negative 1/3. Okay, 81 to the 5/6 times 81 to the negative 1/3. All right. Now I know you all don't like fractions. Okay, so this is where your calculator will come in handy. Notice that the 81s are the same. So the 81 is not going to change. They have the same base. I am multiplying. Whenever I multiply, I add the exponents together. So I'm going to add 5/6 plus 1 plus negative 1/3. Okay, and if I add those together, I would get 3/6. So add the exponents together and I get 3/6. 3/6 is the same as 1/2. Okay, 3/6 is the same as 1/2. In last class, we talked about how you can rewrite a fraction exponent as a radical, right? So we can simplify this one a little bit more. And there's a couple of ways that we can do it, okay? So we talked about how you could change this into a radical. So remember, the bottom number goes in front. So there'd be a 2 in front. And the top number goes on the inside. So basically, it's just what's the square root of 81? And that's 9. Okay? There's an alternative way that we can do this. Okay? So if you look at on our modules page for today, you will see something that says exponent power or power. Okay? And it's a PDF file. And it looks like this. Okay? It looks like this right here. All right? And I've written down a bunch of the powers that might help you. All right? So notice that this problem says 81 to the 1/2 power. Okay, that 2 is really, really important. You want to look at the bottom number. So I look on my chart and I see if I can find 81 on here. Oh, I found an 81 right here. Right? So 9 squared is 81. So I could rewrite 81. This is just another way to solve this problem, guys. I could rewrite 81 as 9 squared to the 1/2. And then remember, when one's inside and outside, we multiply them. So 2 times 1/2 is just 1. So either way, I'm going to get the same answer. Okay? This is the way that I like to do it. I like to change the bigger numbers into smaller ones using this power card. Okay? If you prefer to do it with radicals, you can, but I prefer to do it this way. All right? Hopefully that makes sense, and I didn't go too fast on you. Remember, you can always stop and pause it. All right? Okay, let's look at B real quick, because this one is a little complicated too. So I know it's kind of hard to see. I didn't make it very big. I'll have to change that. But it's xy to the third over x to the 1/2 raised to the 2/3. All right, so what we need to do is first, what I like to do is combine the x's if I can. Okay, like this is x to the first on top, and I have an x to the 1/2 on bottom. So whenever I divide, if you remember back to our very first page that we just talked about, whenever we divide, right, we subtract the exponents. So whenever I divide, I subtract the exponents. So if I subtracted 1 and 1/2, I would be left with x to the 1/2. The y to the third doesn't have anything to go with it, right? There's nothing I can do with the 1/3, or the 3 yet, excuse me. Okay, so I subtracted 1 minus 1/2, subtract the x's, and got 1/2. Now, I have a exponent outside. So now I need to distribute that exponent to the other ones. All right, and if I did that, I then multiply. So I do 1/2 times 2/3, which would be 2/6. You just multiply top times top, bottom times bottom. Then I do the y's. 3 times 2 is 6. The bottom would just stay 3. So I have x to the 2/3 and y to the 6/3. And then I can simplify those fractions. 2 over 6, right? I could divide them both by 2, so I get 1/3. 6 over 3, I could divide them both. Actually, 6 divided by 3 is just 2. Okay? I know it's weird. I know it's weird. Okay, the last one we're going to do is right here, and then we're going to talk about radicals. Okay, so right here, 2a to the 1/3 times ab to the 1/2, all to the 2/3. Okay, so what I like to do first is if there's an exponent outside, I like to distribute it first. Okay, so this first part isn't going to change at all. 2a to the 1/3. And then this second part, this is multiply, right? I'm multiplying a to the 2/3 because it doesn't have anything to multiply. The a doesn't have an exponent. The b has a 1/2 already. So 1/2 times 2/3 gives me b to the 2/6 because I multiply. 1 times 2 is 2. 2 times 3 is 6. So now I have this. Okay. Now I can combine this a with that a because I'm multiplying and they have the same base. All right. Remember, when we multiply things, we add their exponents. So the 2 is not going to change. The a is not going to change. But the exponents, if I added 1/3 plus 2/3, so if you have 1/3 of a dollar and somebody gives you 2/3 of a dollar, you now have 3/3, right? You have a whole dollar. So just a to the first. 1/3 plus 2/3 is 1. b to the 2/6, I could reduce that into just 1/3. I could divide 2 by 2 and get 1, 6 by 2 and get 3. Okay? Hopefully this makes sense. All right, those are our properties of exponents. You're going to get a whole lot of practice with that on your maze in just a little bit. Okay, but here's the last part. The last thing we're going to talk about is what we call properties of radicals. Okay, and we already did part of this in 5.1. If you watched the video, I talked about it, and if you stayed for the live notes, I talked about it as well. Whenever you have a radical and you're multiplying on the inside, you can split it up into 2 smaller radicals. The square root of AB is the same as the square root of A times the square root of B. The same thing when you divide. When you divide, you can split it up. So the square root of A over the square root of A over B is the same as square root of A divided by square root of B. Okay, so you can split up one big radical and make it smaller radicals that are easier to work with. All right, so let's do a couple examples of these. So let's do this first one. It says 16, the cube root of 16x to the 5th power. Okay, so I have 2 things in here, so I'm going to split this up. The cube root of 16 times the cube root of x to the 5th. All right. Now, last class, we were able to just put this in our calculator, the cube root of 16. And if we did that in this case, if I typed in the cube root of 16, let me give myself some space here. If if I did the cube root of 16, you will see that it comes out as a decimal. And we can't have decimals, okay? So we're not allowed to use decimals. So what I need to do, how can I figure this out? What I need to do is figure out a way to turn 16 into something to the third power. So whatever this index is out here, I need to change this number into something to the third power. If this was a 4 out here, I need to make it something to the fourth power, whatever it might be, because my goal is to cancel out that number in front, okay? So that's where this power card is going to come in handy, okay? So 16, if I go to the 3's, the cube column, right? Or I go to the 4th column or the 5th column or the 6th column, or I go to the 2's, wherever it might be, okay? I need to at least the 3's. So 16 is the same as 2 to the 3rd, which is 8, times another 2, right? So 16 is the same as 2 to the 4th power. 2 times 2 times 2 times 2 is 16, okay? I can't do anything with this x to the 5th and x to the 3rd on that side, all right? So I'm just going to keep it the same. Okay, so now what I want to do, all right, this is the last step, and this is the step that people always seem to get a little bit confused on, okay? So now, the cube root of 2 to the 4th. I am looking for a group of 3. I can only cancel out 3 2's, right? I can only cancel out one group of 3. So if there were 4 on the inside, that means 1 2 would go in front. So it's going to be 2 cube root of 2. Because I took out 3, right? I took out one group of 3. That leaves 1 left over. To find the 1 inside, 4 minus 3 is just 1 2 left. Okay? Do the same thing with the x's. 3 will go into 5 one time. So I'm going to put 1x in front. I should have left myself more room. 1x in front. And 5 minus 3 is 2. So that leaves 2 x's on the inside. Okay? I know this is weird. So make sure you are asking me the next time we get together. Okay? All right, let's look at this next one. See if we can make a little more sense of this. So it's one big radical. So I'm going to split it up. The 4th root of 81. The 4th root of 81 times the 4th root of a to the 8th times the 4th root of a to the 5th power. Okay, so I split it up. So the 4th root of 81. So if I go to my card, right, and I look at the 4th root, ooh, 81 is going to be there, right? X to the 4th. So 3 to the 4th is 81. So now there's not going to be anything left. The 4th root of 81, and if you put that in Desmos, you would get 3. 3 times 3 times 3 times 3 is 81. Okay? Now look at this next one. 8 divided by 4. How many times will 4 go into 8? It'll go in twice, so it comes out evenly. So that's just a squared. This next one's not going to be even. 4 will go into 5 one time. Oh, that's a b. I don't know why I put an a over here. I'm sorry, y'all. This is b to the 5th. 4 will go into 5 one time, so that's 1b that would go in front. And then there is 1b left over, because 5 minus 4 leaves 1 on the inside. That is our final answer. Okay? Questions, confused, lost? We're going to do one more problem. Okay, one more. And it is going to be, let's do a division one. Let's do this one. Let's do C. Okay? So the last one. Now it's division, so I'm going to split this up. The cube root x to the 4th y squared over the cube root of 125x. So one big square root I can turn into 2 smaller ones. All right? And then I'm going to try to do this all at once and see if it makes more sense to anybody. Okay? So now, 3 will go into 4 one time. Right? 3 will go into 4 once, so that means 1x will be in front. and that would leave 1x on the inside. 3 will go into 4 once, so there's that. And then 4 minus 3 leaves 1 on the inside. 3 will not go into 2, right? I can't take out 3 y's because I only have 2. So this is going to stay exactly the same, y squared. Okay? Let's do the same thing down here. So now, do each one separately. The cube root of 125. All right? And you can always put this in Desmos first and see if it works. Try the cube root of 125. And it works. It comes out even. The answer is 5. So this is going to turn into 5. There's only 1x right here, right? So I can't take out 3 if there's only 1. So we're done. Okay? Y'all are going to get a whole lot more practice with this. Okay? But if you have questions, please reach out to me. I know this is a little bit confusing, so let me know. Okay, y'all? Thank you.